A rocket scientist, NASA-trained, top of his class, the kind of guy who solves quantum equations on napkins, but still forgets where he parked his car. One night, boom, he wakes up 2,000 years in the past. No satellites, no centrifuges, no nuclear reactors, just aqueducts, sandals, and some very suspicious senators. His name? Mike. And Mike has been given one job by the Emperor of Rome. Build an atomic bomb. Not a road, not an aqueduct, not even soap. An actual world-ending nuclear weapon with unlimited manpower, the brightest Roman minds, and no accusations of sorcery. The big question is, how long would it take Mike to actually build an atom bomb in ancient Rome? A decade? A century? Or would he just invent pizza instead? Let's find out. First things first, the shopping list. Here's what Mike needs. Number 1, uranium-235. Not just rocks, enriched uranium. Only 0.7% of natural uranium is usable for bombs, which means 99% of the rock is useless. Number 2, high explosives, not firecrackers, not Greek fire. We're talking TNT, RDX, shaped charges, microsecond timing. Rome's idea of precision timing was a sundial. Detonate when the shadow hits the goat. Number 3, electronics, detonators, wires, circuits. Romans had copper for jewelry, but transistors, switches, nope. The closest thing to a circuit in Rome was yelling, "Stop pouring wine." Number 4, neutron initiator, a device that fires neutrons at the perfect moment. To a Roman senator, this just sounds like demon magic. Yes, Caesar, I need to build a tiny angry ghost particle machine. Number 5, precision machining. We're talking tolerances smaller than a hair. Romans had swords and bronze statues. Hand a smith a Rolex blueprint and he'd hand you a frying pan. And last, modern chemistry. Rome had vinegar and wine. Mike needs nitric acid, sulfuric acid, nitroglycerin, which means inventing chemistry 1,500 years early. So even before starting, the list looks insane. But let's keep going, because Mike is nothing if not stubborn. Uranium. Where do you get it? Luckily, uranium ore exists naturally. The Romans might find it while mining silver or copper. To them, it's just a weird heavy rock. To Mike, jackpot. But here's the problem. Raw uranium doesn't work. He needs enriched uranium. That means separating U-235 from U-238. How do we do that today? Centrifuges. Machines spinning thousands of times per second. Romans had water wheels. Imagine Mike trying to explain this. Okay, guys, build me a bronze tube that spins faster than a horse can run. The blacksmith. Sure. Why? Mike. So I can separate invisible ghost particles that may or may not exist. Option 2, gaseous diffusion. This needs uranium hexafluoride gas, which means inventing fluorine chemistry. But fluorine wasn't isolated until 1886. That's 1,800 years too late. Option 3, electromagnetic separation, calotrons. Basically giant magnets bending uranium ions. Rome had magnets, sure, but they thought they were magical rocks that ruined bread. So enrichment is the ultimate roadblock. Without it, no bomb. At best, Mike can hand Caesar a heavy rock and say, "Throw this at the enemy. It'll bruise okay, uranium aside." Let's talk explosives. To trigger a bomb, you need high explosives. TNT, RDX, PETN. Rome had none. They didn't even have gunpowder. The best they had was resin, pitch, maybe a little Greek fire. Useful for scaring ships, not splitting atoms. To invent TNT, Mike would need concentrated nitric and sulfuric acid. To get those, he'd need glassware, distillation, and chemistry knowledge. Rome had clay pots and amphorae. So before making a bomb, Mike has to invent laboratories, chemistry, and safety goggles. And if you've ever handled nitroglycerin, one wrong shake and boom. Goodbye, Mike. Goodbye, Empire. Realistically, even with centuries of trial and error, the Romans might only get as far as inventing fireworks, which would still blow their minds, literally. Even if Mike somehow gets uranium and explosives, he still needs precision machining. The implosion design requires perfectly spherical explosives, detonating within microseconds of each other. Romans were fantastic builders. Roads, aqueducts, Colosseum. But these are on the meter scale, not millimeter tolerances. Their most precise tool? A hammer, maybe calipers. And Mike is asking for machining tolerances smaller than a hair. It's like asking a blacksmith to carve a smartphone chip. You'll get something flat and shiny, sure, but don't expect TikTok to run on it. So without lathes, micrometers, or modern metallurgy, the Romans can't make bomb-grade components. And here's the ultimate problem. Romans didn't even know atoms existed. Their universe was four elements: earth, air, fire, water. No electrons, no protons, no neutrons. So Mike has to explain fission, chain reactions, and quantum mechanics to people who still think disease is caused by bad smells. Imagine him pitching it to the Senate. Esteemed Romans, inside every rock are invisible particles. If we smash them, enormous power is released. To a senator. Ah yes, so it's demons. Burn him without centuries of science. The concepts are just too abstract. Okay, so Mike can't make a bomb. But what could he do in Rome? He could kickstart basic chemistry, soap, glass, maybe distillation of alcohol. He could push metallurgy, better steel, better tools. He could explain electricity, maybe even make simple batteries centuries early. With enough time, he could push Rome forward. But nuclear physics? That's locked behind 2,000 years.